Hi, welcome to the second video of the June 2018 Maths Higher Paper 2 Calculator paper. Questions 1 to 6 are on the previous video, so we're starting from question 7, which is similar shapes, scale factors. And the first thing you're going to have to do here is identify a corresponding pair so that we can find our scale factor. Okay. The two shapes are the same way round, you can tell from the angles. And the matching pair, 8.4 and 5.6. So to get the scale factor, we'll need to do 8.4 divided by 5.6. So we've got a scale factor of 1.5. Okay, and that's crucial to the rest of the question, but it doesn't actually get you any marks on its own. Okay, x, that's corresponding with the 3.2, and it's bigger. Okay, so to get bigger, we'll times by 1.5. So 3.2 times 1.5, that makes 4.8. So that's x. And then y is corresponding with the 6.3, but y is on the smaller shape. So easiest way would be to divide by 1.5. So down the bottom there for part B, 6.3 divided by 1.5 is 4.2, and that's centimetres. Okay, so that's the easy mark, says 4 marks. Then part C on the next page, explain why CD can't be 3.9 if RS is 6.5. Okay, so if you remember from part A and B, we already know that the scale factor for those two shapes on the previous page is 1.5. But if you try to do 6.5 divided by 3.9, you actually get a 1.6 recurring, okay, which is a different scale factor. Now there's other ways you can prove it. You can times 3.9 by 1.5 and it doesn't come out 6.5, or you can divide 6.5 by 1.5 and it doesn't come out as 3.9. As long as you've got some evidence that it's a different scale factor to what we used for the rest of the question, okay, or the scale factor 1.5 doesn't work with those two numbers. And there you go, that's the end of question 7. Question 8 then is simultaneous equations, and the easiest way of spotting that is because you've got x's and y's in the same question. They haven't given us the equations though, we're going to have to come up with our own, and that's what the two shapes are for. So top shape, there's a rectangle. It tells us that it's 12 wide and it's 2x minus y tall, and it tells us that it's got an area of 72. And probably the easiest thing to do with all of those numbers, because you know the width is 12, if you do 72 divided by 12, you'll get 6. And from that you can make an equation, because that tells us that 2x minus y must be 6, because 6 times 12 is 72. You can expand out 12 and then 2x minus y in a bracket and put it equal to 72, but you'll get some massive numbers if you do it. It should still work though, so if you've done that, just bear with me, you should still get the same answers at the end. Okay, for our kite, we're told the perimeter. Perimeter is when you work all the way around the shape adding up the sides, so that's another 3x, that's a y, because the kite is symmetrical. And from there, if you work your way around adding up all of the sides, you get that 6x plus 2y equals 33. We were told the 33 in the question. Okay. Now, I'll try and work here, because I don't want to go over the page. So I'll work on the side. So our two equations are 2x minus y equals 6, that's equation number 1, and 6x plus 2y equals 33. And our first job is to get these matching so that we can take away. To get them matching, I'm going to times the top row all by 3 to make it 6x, and I don't have to do anything to the bottom row then. So our new equation underneath there, if we times the top one by 3, gives us 6x minus 3y equals 18. Okay, so now I don't need that one at the top now. So let's put a line across there. I'm just using the blue and the green now because they're matching. So let's do some taking away. 6x take away 6x is nothing. Then we've got plus 2y take away minus 3y. 2y, take away minus 3y. 2 minuses make a plus. You actually end up with 5y under there. Okay, be careful with your signs. Taking away a minus, that becomes an add. And we get 15. If you divide by 5, you get that y equals 3. Okay, and we're halfway there. Now we've got to substitute that back into one of our equations. You can substitute it into either of the blue ones. Doesn't really matter. If I substitute it into, if I label them 1, 2, 3, if I substitute it into number 2, for instance, so equation 2 says that 6x plus 2y equals 33. I know that y is 3 down here, so 2 3's must be 6. So 6x plus 6 equals 33. Take away the 6, leaves us with 27. And then divide by 6, we get 4.5. So x is 4.5 and y is 3. There's a couple of different ways of doing that. I think that's probably the easiest though. Get your matching x's and take away. Okay, and that's the end of that question for 5 marks. Okay, number 9. We've got more right angled triangles. We had some earlier on in the paper and it was Pythagoras. This time we've got angles, so this must be trigonometry. And our first job, question 8, is to find the size of angle X, which is sort of in both triangles. But to find it, we're going to use triangle ABC. That's this one here. And what we've got for triangle ABC is 2 sides. We're trying to find an angle. It's definitely trigonometry. We need to label our 2 sides. Remember, for trigonometry, it's opposite, adjacent, and hypotenuse. If the angle is at the top, then the bottom must be the opposite. We don't know anything about the hypotenuse. That runs from A to C. So this must be the adjacent, which is 10.4. If we've got the opposite and the adjacent, SOHCAHTOA tells us that this is a tan question, opposite and adjacent. So tan theta, or tan x if you like, is O over A. So tan x equals 6.5 over 10.4. If you're trying to find an angle, we need to do the opposite of tan, which is tan to the minus 1. So what you actually type into your calculator is tan minus 1 of 6.5 over 10.4, and that comes out as about 32 degrees. Okay, to the nearest degree, 32 degrees. Okay, now part B is on the next page, but I've moved it so we can do it all together. Now we've got to find the length of DE. Now DE is part of this separate triangle. I'm going to redraw it. So D to E looks something like this. CDE. And what do we know? We've got a hypotenuse of 9.4. We've got a right angle there. And the angle at the top there is the 32 that we've just worked out and the 22 which is there. So that's a total angle of 54 degrees. Okay. And D to E is what we're working out, so I'll put an X there. So trigonometry again. 54 is at the top, so X is the opposite side. 9.4 this time is the hypotenuse. This is a sine question now then. Okay, opposite and hypotenuse is the sine part. So we've got that sine 54 equals, now let's go back up, it's O over H, so X over 9.4. To get X on its own, we need to bring the 9.4 over and it will change to a times. So if you type into your calculator, 9.4 times sine 54, you should get an angle, a length of about 7.6 centimetres. You can be a little bit more accurate if you like. The mark scheme works to 1 decimal place, so 7.6 centimetres. Helps to draw it out separately so you can see what you're doing. It's a bit muddled when they're overlapping there. Okay. Number 10. Don't normally see factorising on a calculator paper. Okay, but here we are. And this is a different type of factorising. Hopefully you're going to spot here that because we've only got two terms, because they're taken away from each other, and because 4 is a square number, and so is 289, but you may not realise that straight away, that this is actually the difference of two squares, which is a very special type of factorising. Okay, so difference of two squares. And when you're factorising with a difference of two squares, we know that it's two brackets. We know that one's a plus and one's a minus. And to get the individual terms, what you'll need to do is to square root both parts of the original expression. So the square root of 4m squared is 2m, because 2m times 2m makes 4m squared. Okay. Now remember, you've got a calculator for this bit, so the square root of 289 is actually just 17, so plus 17 and minus 17, but you've got to keep an eye out for difference of two squares. And then question 11 is about the volume of a pyramid. Now you're not given the formula for the volume of a pyramid. There's two ways you can do it. You can do a third of A, B, C, okay, where A, B, and C is the height, okay, or you can say that it's 1/3 of the base area times the height, which is the same thing, because A times B gives you the base area and C is the height. Okay. In this question, we are given the base area, so it makes more sense to use the second of the two formulas there. So the base area, that's this bit down here, is 13,200. So we've got 1/3 times 13,200 times the height, the perpendicular height, which is 460. We're working all in centimetres here, so these are going to be some big numbers in a second. And that comes out as 202,400 centimetres cubed, so 2,024,000 centimetres cubed. Now it does ask us to give our answer in metres cubed. Not the easiest conversion. If you imagine a 1 metre cube, so 1 metre wide, 1 metre there, and 1 metre there. Okay, so 1 times 1 times 1, so that is definitely in metres, 1 metre cubed. But in centimetres, which is what we're working out in, that would be 100, this would be 100, and this would be 100, and 100 times 100 times 100 is 1,000,000. Okay, so 1, 2, 3, 4, 5, 6. So the conversion is that 1,000,000 centimetres cubed make a metre cubed. We've got just over 2,000,000 centimetres cubed. So divided by 1,000,000, we get 2.024 metres cubed. Okay, be careful with your conversion there. Right, I'll stop this video and we'll do question 12 onwards in the next one.